All right, so now we come up against a guy named Lewis, as in the Lewis dot structure. Lewis was a lazy fella. He thought the periodic table, and thinking as hard as we were making it thinking last assignment, was too hard for good chemists. He thought, all you have to really know is what's going on in the outer shell and whether or not we're donating electrons or receiving electrons. So he said, look, this first column all has one extra electron. Whoa. That wasn't what I meant to do. Let's see if I can back that up. All right, there you go. Okay, this first column all has one electron. So it's like they have one electron in the outer shell. This one has two electrons in the outer shell. This one has 3. This one has 4 in its outer shell. Boop, undeniable truth. This one, now we're going to get a little tricky here. This one has 5. Its outer shell, right? Nitrogen needs to lose 5 electrons once we get down to hydrogen. This has 2 helium. This has 2. This has 7, so it loses 5. This one has to lose 6. Of course, we're not talking about losing 6 anymore, are we? Right? And then fluorine has 7 in its outer shell. Really wants 1 more so it can become like neon. And so he said, look, if that's the case, that's all I care about. So I'm going to do something, use a notation that's going to make sense. Specifically, I'm going to say that hydrogen has 1 electron in its outer shell. Lithium has 1 in its outer shell. Bam. Beryllium has 2 in its outer shell, so I'm going to put 2 dots on it. I'm going to say boron has 3 dots. I'm going to say carbon has 4 dots. I'm going to say nitrogen has 5 dots. I'm going to say oxygen has 6 dots. Say fluorine has 7 dots. And then neon, which is perfectly happy because it has all 8 of its dots. And so he said, look, all you have to do is know it's an outer shell, so I'm going to draw with the dots already on in there because it's too hard to figure out what's going on. Now, there's a couple things we should be alerted to. Let's talk first about aluminum, because aluminum's problematic. Why? Aluminum has 3 in its outer shell, but let's talk about the next one below it. This is, let's talk about bromine. Okay? Bromine, as you're aware, has 17 in its outer shell, but we're going to pretend like it's got 7. How is that fair? The answer to the question is, it wants to gain 1 electron, right? So it acts like it's got 7 and only wants 1 more electron. So although we should put a 17 around it, Lewis is too lazy to do that. Lewis simply says, we're just going to treat it like it has 7. This whole family has got 7. This has got 6. This has got 5. That's got 4. That's got 3. That's got 2. That's got 1. This has all got 8. And we're not going to worry about the fact it really has 17 because it's not my problem. Okay? All right. So go ahead and fill out your whole entire table. Use all the Lewis dots. Make all the dots on all of them. Again, all your families should look the same. Hopefully this won't be that hard. So for example, calcium right here should have 2 dots, right? Boom, boom. Okay, that's it. That's all you have to do. So do that for the whole entire table. And then I'll come back to you in a second, and we'll talk about what to do next. So the whole point is to make your life better. So if I use my periodic table, which is over here, and I want to know how many dots are on silicon, I count over from the left. 1, 2, 3, 4. There's 4 for silicon. So silicon acts like it's got 4 electrons on the outside shell. Okay, 1, 2, 3, 4 on the outside shell. Call it a day. Let's look at one on the right-hand side. Iodine. Iodine's way over here. It needs 1 more to get a full 8. Yes, but it needs 17. Okay, just deep breath. It's all right. We're just going to pretend like it's got 7. We're done. Okay? All right, so go ahead and do those sets, and then we'll get down to the next idea. Okay, so how does this make our life better? The harder it gets, the harder these problems get, the easier it makes my life. So these are going to be easy problems. So it's not exactly the best choice, but here's strontium. Strontium has 1, 2 electrons in its outer shell. It's this one right here. Again, count in 2, it's got 2. So we're going to act like chlorine. Chlorine's right here. It's 1 away from argon, so it's got 7. So I'm going to put it so it's ready to have a chemical reaction. So I'm going to put chlorine right here. We're going to say it has 1, 2, 3, 4, 5, 6. Now, here's where things get interesting. This has a hole, right? So I can say, all right, strontium is going to get a little closer and fill in that hole. So we're going to go ahead and put strontium in there. We'll put strontium right here. Strontium fills in that hole. Now, chlorine's happy. Strontium has gotten rid of its electron. Now what? Strontium's also got one sitting over here. So what's next? I put a chlorine over here. 1, 2, 3, 4, 5, 6, and then here's 7. Chlorine's got a full shell. Chlorine's got a full shell. Strontium's lost everything, so it's got a full shell. So it's the formula is strontium. The one on the left goes first every time. We haven't talked about that enough yet. Strontium, chloride, but it took how many chlorines to suck up those 2 electrons? It took 2. So strontium chloride is SrCl2, and that's how you do these problems. Got it? Let's do magnesium chloride. Try magnesium chloride. Pause this, and I'll do magnesium in just a second. Magnesium chloride in just a second. Okay, so I'm going to do magnesium chloride now. If I look at magnesium, magnesium is where on the periodic table? It's right here. It needs to donate 2, so I assume it's got 2 in its outer shell. Boom. 1 here, I want to get rid of. 1 here, I got to get rid of. Chlorine is right here. It's got 7, so I'm going to put a chlorine right next to it. Chlorine 1, 2, 3, 4, 5, 6. I already filled my shell. I'm going to have to put 1 here, so now I've got a full shell around chlorine. Magnesium's not happy. It's still got this one sitting here that's still with it. So I'm going to put a chlorine right here. 1, 2, 3, 4, 5, 6, 7. Now I know that everybody's happy, right? Full shell, no shell at all, which is the same as having full shell because now I'm at the next shell down. And so that's MgCl2. Finish this. Please send it to me. I'm curious about this one. This is the beginnings of doing actual chemistry. And no matter what class you take next, there is going to be some chemistry in it. So I need you to know some basic chemistry. So make sure that you're following along the best you can. All right. Thank you.